Hey everyone, so with final season breathing down our necks, we know the pressure is really on. That's why today we're doing something a little different. We're going to give you a complete strategic playbook for acing your algorithms final. And get this, it's built entirely from your professor's own words and advice from a recent class. All right, let's jump right in. Yes. The classic question that probably keeps you up at night, right? You've got months of material, so where do you even start? How do you make sure you're spending your precious time on the right topics and not just spinning your wheels? Well, here's the good news. Your professor has basically handed you the treasure map. You just need to know how to read it. And that's what we're going to do right now. We're going to break down everything that was said in class and turn it into a super clear, actionable study plan. Okay. First things first, before we can talk strategy, we need to see the whole playing field. Let's get that bird's eye view of every single topic that could, in theory, show up on your exam. So here it is, the whole shebang. You started with the absolute basics, right? What an algorithm even is. Then you built up through things like complexity analysis, recursion, sorting, and graph algorithms. And then you got into the real heavy hitters, dynamic programming, string matching, and you finished up with computational geometry. This is the entire universe of topics for the final. Now, this is where it gets really, really good. Out of that entire syllabus, your professor didn't just hint, they straight up told you about 2 topics that are guaranteed to be on the final. I mean, come on, that is pure gold for studying. And there you have it. Clear as day. The first guarantee is a question from string matching. So you're going to want to pour your energy into understanding the Knuth-Morse-Pratt algorithm, KMP, and its sidekick, the longest prefix-suffix array, or LPS. This isn't a maybe, folks. This is a definite. And here's the second mandatory question. Geometry. The professor was just as direct about this one. When you're studying geometry, you need to laser focus on those 2 convex hull algorithms you covered, gift wrapping and gram scan. Knowing for a fact that these 2 topics will be on the exam is a massive strategic advantage. Okay, so knowing what is going to be on the test is a huge deal, but that's really only half the battle. Your professor also laid out exactly how you're supposed to answer the questions to get full marks. And spoiler alert, it's all about showing you understand, not just that you've memorized. He basically gave you 4 golden rules for how your answers are going to be graded, and these rules tell you everything about the exam's philosophy. It's all about demonstrating your process, explaining the why behind the what, analyzing code, and visualizing your logic. Let's dig into each one. Let's use that LPS array as an example. Look, if you just write down the final array of numbers, you're going to get almost 0 points. You have to show the simulation. For every single value you calculate, you need to say which rule you used, case A, B, or C, to get that number. They want to see your brain working, not just the final result. Now, this next point is absolutely crucial. This idea of inner meaning. Forget trying to memorize some textbook definition word for word. That's not the goal. The real goal is to prove you get it. If you're asked about KMP, explain in your own words that it's a clever way to find a pattern in a text. Showing that you actually understand the concept is what's going to earn you the points. And what about code? Well, here's some good news. Don't spend all your time trying to memorize pages of complex code. The professor was really clear that you're way more likely to be given a small code snippet and just be asked to analyze it. What does it do? Which algorithm is this part of? It's all about comprehension and making connections, not just rote memorization. And for that other guaranteed topic, geometry, let's be absolutely crystal clear. If you get a convex hull question, drawing a diagram isn't just a nice to have. It is essential. You have to draw it out. It's a non-negotiable part of getting a complete answer. All right, let's switch gears and cover some of the other key details you need to know, from your final assignment to a few quick facts about the exam itself. First up, a simple but really important number to keep in your head. The final theory exam is going to have exactly 6 questions, and since you already know 2 of them for sure, you've got a pretty solid idea of what you're walking into. Okay, let's talk about your final assignment. And honestly, it's designed to be the ultimate study tool. Your task is to create a personal set of notes covering every single topic from the entire semester. It doesn't have to be pretty. It can be rough notes in a notebook. What really matters is that it contains your own reflection, your own understanding of all the material. Now, I know there was some talk earlier about a page minimum or something, but the professor has clarified. Forget the page count. That's been removed. The focus here is 100% on quality, not quantity. Your grade is going to be based on how well your notes show a deep understanding of the course content,
not on how many pages you manage to fill up.
Quick but super important clarification here. Everything we've been talking about is specifically for your theory exam. The lab final? That's a whole different beast. You'll be expected to actually write and implement algorithms. And the on-site contest will pull its problems straight from the marathon contests you've already been doing. So different exams mean different study strategies. You know, this one quote from your professor really just ties everything together perfectly. It's not a test of your memory. It's a test of your understanding. The whole point is to see if you've truly grasped the why and the how of an algorithm before you went and memorized the steps.
So as you buckle down for these last few days of studying, this is the one question you need to keep asking yourself for every single topic you review. Are you just memorizing facts, or do you actually truly understand it? Because if you can honestly answer yes to that, you're not just going to pass this exam, you're going to master the material. Good luck.